Although we can find all the information that we'll ever be asked with the kinematic equations, and really with just the first two kinematic equations, sometimes it's nice to have slightly modified equations that we can use quickly and easily in particular circumstances. So one of these will be the maximum height equation, which just comes from the kinematic equations. So let's review this kinematic equation here. Say we have v squared is equal to v naught squared plus 2a and delta something. Let's work in the y direction to ay delta y, which makes this vy squared v naught y squared. So let's take a look at this kinematic equation, and remember our delta y here would be our vertical displacement if we have a coordinate system like this where y is upwards and x is to the side. So this is our displacement. And if we're looking for the maximum height, we also know that at the max, we know the y component of the velocity at the top, vy top, is equal to 0. So let's just modify this equation here for this particular circumstance when the vy final, vy at the top, is equal to 0. So then we have 0 is equal to v naught y squared plus 2 ay delta y. And now if we were given a velocity with a magnitude v naught and some angle theta in standard position, where theta is measured in standard position, then we can find v naught y. So we can say v naught y is equal to v naught sine of theta. This is when theta is given in standard position, which, unless it's otherwise stated, it is given in standard position. We also, if we are on Earth, then we would have, and we use the traditional coordinate system where we have positive y upwards, then our acceleration in the y direction would be downwards gravity, negative g. And delta y, because we're starting here at time equal to 0, so time equals 0 here, and then we have some later time up here. Time is, I guess, when we get the maximum height, time at y max. Then our delta y is going to be positive, right? And so then we can say, delta y will be greater than 0, displacement will be positive. And so then let's say delta y is just equal to our height. Okay, that's how high something is here. So let's take these and plug them in to this. And so we get here 0 is equal to v naught sine of theta, and this is all squared, plus 2 times negative g h. And so then just rearranging, we'll get 2gh is equal to v naught squared sine squared theta. And we can solve this for the height, and we get height is equal to v naught squared sine squared theta over 2g. This is what we call the max height equation. So the maximum height is just the magnitude of the velocity squared. This is, by the way, this is just v naught. This is the magnitude of the velocity times the sine of theta squared divided by 2g. And remember, g is not a negative. Otherwise, if g was negative, we'd get a negative maximum height. G is positive. Sometimes this can be written differently. You might see this as just written as v naught squared sine squared theta is really v naught y. So this is v naught y squared over 2g. This is the same thing. It's just written a little bit differently. You could also do it directly from the kinematic equations. Delta y is equal to v naught y squared over 2g. These are all the same thing, but the height equation is oftentimes given like this. So as long as we have a angle and standard position, a traditional coordinate system with a positive x to the right and a positive y upwards, and we're on Earth, so that our acceleration due to gravity has a magnitude of g, then this is our maximum height equation, which just comes from the kinematic equations.